Welcome to the Shenandoah Valley Agricultural Research and Extension Center, or as many folks around here call it, the Cyrus McCormick Farm. This isn't just any research station tucked into the mountains. This is a living legacy of innovation. Right here on this land is where the McCormick Grain Reaper was born. A simple yet revolutionary machine that didn't just change farming here in Virginia. It transformed global food systems and reshaped the human relationship with agriculture. Pretty big shoes to fill, right? But that spirit, that drive to do things better, to build systems that work smarter, not just harder, still runs deep here. Today, we carry on that same spirit of innovation, not with gears and steel per se, but with roots and ruminants. My name is Summer Thomas, and I did my Ph.D. research here at the McCormick Farm, focusing on rotational bale grazing, which we'll dive into more later when we get into the winter segment. But beyond research, this place has become a kind of home base for learning, not just for me, but for a whole network of producers, students, and conservation professionals. Because what we do here isn't just theory. It's boots on the ground, foot in the dirt, hand in the soil, grazing management. We test real-world strategies that work under pressure, under hooves, under weather swings, and under the very real demands of running a working operation. Our goal, resilience, for soils, for plants, for animals, and for the people managing them. We're not just chasing quick fixes. We're building systems that last, that feed herds, support livelihoods, and leave the land stronger with each season. Now, my name might be Summer, but this story spans all 4 seasons. Because when we talk about good grazing, we're not just talking about right now, we're talking about year-round management, or at the very least, extending the grazing season. To reduce reliance on hay, lower input cost, and keep living roots in the ground as much as possible. It's not just possible, it's practical, and it can be profitable. Every season has a job to do, and every plant has a role to play. And every decision, whether it's stocking density, rest period, species selection, or winter feed strategy, should be made with intention. So here's what we're doing today. We're taking a pasture walk through the calendar. Spring, summer, fall, and winter, to explore how we grow high-quality forage, manage grazing pressure, cut costs, and build soil health every step of the way. We'll look at what's growing, what's resting, what's being stockpiled, and how to make decisions to work with nature instead of against it. Sound good? Let's walk. Spring is the opening act of the grazing season. The soil warms, roots reach down, and cool season grasses like tall fescue, orchard grass, and clover take center stage. These species form the backbone of your grazing system. Manage them well now, and you'll reap the benefits all year long in forage production, animal performance, and soil health. First things first is to know your players. Plant ID is not just for trivia night. It's a diagnostic tool. What's growing above ground gives you insight into what's happening below. Soil fertility, compaction, pest management, and more. In the paddock I'm standing in now, this is mostly tall fescue, the most common cool season grass in our region. It's tough, it's drought tolerant, and productive. You'll recognize it by rough, sandpapery leaves, round, hollow stems, and a bunch growth habit. It's upright and it has a dark green canopy. But here's the catch. Not all tall fescue is created equal. Kentucky 31 fescue carries a toxic endophyte fungus that produces alkaloids, restricting blood flow in animals. The result? Heat stress, poor weight gain, and in severe cases, lameness, what we call fescue foot. If you see cattle crowding ponds on a cool spring day, that might be a red flag. Here at the AREC, the crew is transitioning to novel endophyte tall fescue varieties. These varieties maintain the persistence of fescue without the toxic effects. I'm standing in a Kentucky 31 paddock right now, and just to my left is a newly renovated field. Visually, they're going to look the same when you compare the tall fescue, but one supports better animal health. Since you can't ID toxic endophytes levels visually, lab testing is going to be your friend. If the results suggest that you've got a problem worth fixing, or even just your own observation, renovation, like the AREC is doing, is one path, but it's not your only option. It can be quite expensive. Other strategies include interseeding legumes like clovers to dilute toxin intake, managing grazing height. Toxins are going to concentrate in that seed head, so clip when needed. Avoiding overgrazing the base, because that's where alkaloids are also going to concentrate. Using shade like silvopasture cools cattle and adds forage diversity. Orchard grass is another key player in cool season pasture systems, especially in Virginia. It's valued for its early spring growth and rapid regrowth potential and high palatability, particularly when it's kept in its vegetative state. Compared to tall fescue, orchard grass has softer leaves and a sweeter taste. So in this pasture, we've got both orchard grass and tall fescue. We can see the difference here mainly with color. That's what does it for me. Orchard grass tends to have more of like a bluish tint. So if you're to look out in your pasture and see more of a bluish tint, the dominant species is likely orchard grass. And tall fescue's kind of got that darker green color. So here's the orchard grass with its V-shaped leaves. It's soft and tender. When you rub your finger against it, it doesn't have really any stubble. With our tall fescue, when we run our finger across it, you're going to get more of a sandpapery texture. And we can see that kind of darker green. It's not as tender as our orchard grass is. Legumes like white and red clover are nature's nitrogen factories, and they can play a powerful role in both soil fertility and forage quality. Through a symbiotic relationship with rhizobium bacteria, legumes are able to fix atmospheric nitrogen and convert it into a plant-available form, essentially fertilizing the pasture as they grow. The amount of nitrogen fixed can vary widely depending on conditions, ranging from as little as 20 pounds of nitrogen per acre per year in low-performing stands to more than 300 pounds of nitrogen per acre per year in vigorous, well-managed ones. Say nitrogen fertilizer costs was about 40 cents a pound. That's equivalent to $8 to about $120 an acre, which can significantly reduce input cost over time. And that's at 40 cents a pound. Think about that. But legumes do not work for free. They need the right conditions to thrive and fix nitrogen effectively, including soil pH between 6 and 7. Legumes are very sensitive to acidic soils. A pH in this range ensures healthy rhizobium activity and nutrient availability. A big one is proper inoculation at seeding, especially when introducing legumes into a pasture where they have never been grown before. Inoculation ensures the correct strain of rhizobium is present to kickstart nitrogen fixation. Also, light rotational grazing will keep your stand healthy. Legumes, particularly white clover and red clover, don't tolerate intense defoliation as well as grasses. Overgrazing can reduce persistence and weaken the stand. A rotational system that leaves some residual helps protect growth points and root reserves. Also, nitrogen might be covered, but phosphorus and potassium need to be sufficient for our legumes to support root development, nutrient transport, and regrowth. White clover. That's going to be a low-growing, persistent, and spread by stolons, making it excellent for grazing systems, especially with cattle. Red clover. That's going to be more upright and short-lived, typically 2 to 3 years, but it contributes a burst of productivity and nitrogen especially in its first year after establishment. Both species improve forage quality, boosting crude protein and digestibility across the pasture. Including legumes in your system not only reduces the need for synthetic N, but also diversifies the plant species, extends the grazing season, and improves resilience to weather and pest pressures. Just like any good teammate, they need support. But when managed well, legumes can do a lot of heavy lifting. Pasture's cast of characters tells a story. A solid fescue monoculture may indicate low pH or historically overgrazing. No legumes, that means higher fertilizer cost. Learn to read what the land is telling you. Broom's edge. It's not as visible right now, but if your pasture looks like a broom factory, chances are you've got low phosphorus and low pH, and likely a history of overgrazing. You might not recognize it now, right now we're in August, but come November and December, it stands out like a sore thumb. And then buttercup, those pretty yellow flowers. Yeah, they're pretty, but persistent in wet and compacted soils. Don't just spray and pray. Ask what the weed is telling me about my management. Instead of grabbing a sprayer, grab a soil probe. Let's pause for a second. I just mentioned silvopasture. Silvopasture is the intentional integration of trees, forage, and livestock on the same land. It's not just turning cattle loose into the woods. It's a managed system that brings real benefits to both animals and land. Done right, silvopasture can lower heat stress and improve animal performance, extend grazing days by providing diverse forage types and microclimates, and improve soil health through increased organic matter and water infiltration. A big thing is it adds long-term value for your land. I've heard it all. Why the heck would I put trees into my pasture? But think about future generations. It could be future timber, nut crops, or wildlife habitat. Here at the AREC, we're experimenting with different silvopasture options. I will say it's a system that takes time to build, but the benefits are worth it. It's another way we can work with nature, not against it. So whether you're planning a pasture renovation or just tweaking your spring rotation, think beyond the grass. Think about structure, diversity, and long-term resilience. Orchard grass can thin out over time if it's mismanaged, especially in systems that rotate too quickly without adequate rest or continuously graze paddocks, when animals graze too low, too often. It's also more susceptible to heat and drought stress, which will hit hard in the summer. During those periods, extended rest periods and grazing deferment become even more important. Overgrazing and heat can take out orchard grass for good, so plan ahead during seasonal transitions. That said, when it's given the right recovery windows, orchard grass can stay productive into summer and bounce back strongly with fall moisture and cooler temperatures. Its regrowth curve makes it a valuable part of spring and fall grazing, and it can even be a nice contributor to late-season stockpiling when conditions are right. Including orchard grass in a species mixture with a hardier grass like tall fescue or those nitrogen-fixing legumes like red clover, white clover, birdsfoot trefoil is a smart way to buffer its weaknesses while still benefiting from its high forage quality. It's a great example of how diversity strengthens pasture systems. Not every species need to be perfect, they just need to work together. By midsummer, cool season grasses hit a wall and growth slows. Forage quality drops, and before you know it, you're feeding hay in July. Welcome to the summer slump. But here's the thing, it doesn't have to be that way. Enter native warm season grasses, the true workhorses of the summer grazing season. Some of the most valuable species include big bluestem, Indian grass, switchgrass, and eastern gamma grass. While your tall fescue and orchard grass are sweating it out, these species are just getting started. They thrive in heat, push through drought, and continue producing high-quality forage when other grasses shut down. And it's not just about what's above ground. These native grasses send roots 6 to 10 feet deep. tapping into soil moisture that cool season grasses can't reach. That deep rooting means exceptional drought tolerance, improved water infiltration, greater carbon sequestration, and long-term soil structure stability. They don't just fill the gap, they transform the summer forage landscape. Warm season grasses also produce high biomass and can maintain excellent forage quality when grazed at the right stage. Livestock perform well on them, especially when paired with good rotation and mineral supplementation. Now, let's talk establishment, because that's what usually scares people away from native warm season grasses. While the payoff is big, the process takes patience. Establishing native warm season grasses isn't like drilling a ryegrass and seeing green in a few weeks. You're investing in a system that can last 15 to 20 years or more. But it might take 2 or more growing seasons before you see full potential and production. Some years may require reseeding or spot touch-ups, and that's normal. Don't let that scare you. These grasses start slow, but they're strong to stay. Want the best advice? Talk to someone local who's done it. Ask what worked, what didn't, how did they manage weed pressure, what seeding rate gave them a strong stand, how did they time their planting with spring rain or soil temperatures. A little local knowledge can go a really long way. But no matter what you do, I can't stress this enough, don't skip the most important step. Rule number 1, eliminate competition. Cool season grasses and weeds will outcompete your warm season seedlings if they're not controlled before planting. But you've got options. Use cover crops to prep the site and suppress weeds. Use tillage to create a clean, firm seedbed. Use herbicide burn downs to reduce competition from fescue, annual grasses, or broadleaves. Whatever method you choose, just make sure your seedlings aren't fighting for space and sunlight in those first critical weeks. Success starts with a clean seedbed and a clear strategy. Native warm season grasses may not be instant gratification, but they are long-term insurance. They give you summer forage, grazing flexibility, and a way to keep your animals on pasture, not on hay, during the hottest, driest part of the year. With warm season perennials in your system, you're not just avoiding the summer slump, you're building a pasture program that performs 12 months out of the year. Let's talk about common mistakes when establishing. The first, of course, is skipping step 1. That biggest error is not properly eliminating existing vegetation before planting. Warm season grasses, as we said, are slow and weak early on, and cool season grasses will outcompete them if left unchecked. Take the time to kill off old sod, use burn down herbicides, or employ tillage to create a clean, firm seedbed. I know it sounds repetitive, but I can't say it enough. Using low quality seed or wrong varieties is another common mistake. Make sure to buy certified seed from a reputable source. Some seed mixes labeled native have a lot of weed seeds or less adapted varieties. Choose varieties suited for your region and your soil type, and be wary of overly cheap seed that's going to cost you more in the long run. So yes, weed management before, but it doesn't stop there. Ignoring weed management after planting is a big mistake. Native warm season grasses need to be protected during establishment, which often means follow-up weed control. Don't assume planting the seed is the last step. Monitor your fields, and if weeds start to take over, use spot treatments or plan grazing to reduce competition. But there's that word grazing. Overgrazing too soon is a big mistake. Warm season grasses need time to build their root reserves, and grazing or mowing too aggressively in the first year will set them back. Let plants grow to at least 18 inches before the first grazing, and always leave enough residual for regrowth. Let's discuss cost share because, as we said, this is a big investment and it can be expensive. If the upfront cost of establishing native warm season grasses is daunting, remember you're not alone, and there are programs designed to help. NRCS and the EQIP program. Many state NRCS offices offer cost share assistance through EQIP to help with warm season grass establishment. This can include payments for seed, site prep, fencing, and even watering systems. Check with your local USDA service center for eligibility and application deadlines. State soil and water conservation districts. Soil and water conservation districts often run programs or partner with NRCS to provide technical assistance, cost share funds, or grants for pasture improvement projects. They may also offer free or low-cost soil testing, planting guides, and hands-on workshops. Speaking of soil testing, think about extension agents. Local extension offices can connect you to regional resources, research, updates, and even producer networks. Sometimes they also have demonstration plots or seedling giveaways to support adoption. A few tips when applying for cost share is plan ahead. Many programs have specific application windows that may close well before planting season. Have a clear management plan. Programs want to see that you understand the steps involved in establishment and ongoing management. Keep good records, which you should be doing already. Document your site prep, planting dates, seed purchases, and any follow-up treatments or grazing. This helps with compliance and tracking success. The biggest thing I can say is don't hesitate to ask for help. NRCS, Soil and Water Conservation District, plenty of other extension agents and staff are there to help you be a matchmaker to find the right grant for you or right funding for you. They'll help you through the paperwork and planning. Now let's shift gears for a second and talk about summer stockpiling. In my opinion, one of the best kept secrets in grazing management. In spring, your cool season forages often grow faster than your herd can eat. Instead of mowing it down or letting it go to waste, you can set some of that forage aside, leaving it to grow untouched, and save it for the late summer months when pasture growth slows and the slump hits. Summer stockpiling paired with fall stockpiling becomes a powerful, low-cost grazing bridge that can carry you from July all the way through winter. So let's think about a stockpiling timeline, planning across the seasons. So April to mid-July, you can select paddocks with strong, healthy, cool season growth and exclude livestock from those and give them complete rest during this time. This paddock becomes your summer stockpile. Mid-July to mid-August, you can continue growing that summer stockpile in these selected paddocks and simultaneously prepare about 50% of the rest of your total acreage for fall stockpiling, whether that's by resting or targeting fertility. Then mid-August to October come, and you could begin strip grazing your summer stockpiled forage, letting animals harvest it gradually. And then you'll also be resting all the other pastures to recover and prepare for fall stockpiling. October to December, after depleting the summer stockpile, switch to limit grazing on the pastures that were rested but not used for fall stockpiling. This helps maintain pasture condition through late fall. Then December to February come around, and finally, you can begin strip grazing your fall stockpiled pasture, extending grazing well into winter. So we just covered 2 seasons there. What's the benefit? You bridge summer and fall dry spells, keeping livestock on forage longer. You extend grazing days well into winter, reducing feed bills. You delay or sometimes eliminate hay feeding, saving time and money. You build soil health by minimizing mechanical harvest and maintaining continuous plant cover. You give pastures time to rest, to recover, and improve future productivity. Smart stockpiling is more than just saving feed. It's about building flexibility, resilience, and healthier pastures that can support your herd through challenging seasonal transitions. Don't let the summer slump catch you off guard. Plan ahead, manage intentionally, and let your pasture do the heavy lifting. We mentioned rotation earlier. Let's unpack that a little bit more. If we were to look down there where the cattle are grazing, that's going to be the same soil, same rainfall, same forage species compared to the paddock that I'm standing in right now. But there is going to be a contrast. Down there, you've got continuous grazing. That's going to be short, uneven patches, plants graze to the ground and struggling to recover. Animals go back for the best bites again and again, and over time, the weaker species drop out. The pasture loses diversity and resilience. On the other side, we've got rotational grazing. Uniform growth, deep green color, and better overall coverage. The big difference is rest. Rotational grazing isn't complicated. It's not about building fancy fences and moving animals every hour on the hour. At its core, rotational grazing is about one thing, which is recovery. You're giving plants the time they need to regrow leaf area, rebuild energy reserves, and push roots deeper into the soil. That recovery is what drives productivity. It fuels photosynthesis and fuels soil biology and increases the stand's ability to resist drought, compete with weeds, and bounce back after stress. Think of leaves as factories. They capture sunlight and build the plant's structure. Leaves feed the roots, roots feed the leaves. If you were to graze every plant down to a nub, you shut down the factory. The whole system stalls. But if you leave enough leaf area behind, the plant can bounce back faster and stronger. So, what are the basics? Start grazing when forage reaches about 8 to 10 inches. That's when you've got a good canopy of leaf area and strong photosynthetic capacity. Stop grazing at 3 to 4 inches. That's the critical stubble height. Remember that grazing stick I showed you all earlier? Great tool. When you leave enough factory floor, you're able to kickstart regrowth immediately. Then rest again until it hits about 8 to 10 inches and return those animals. It's not about the calendar, it's about plant height. Cool season forages grow fast in spring and fall, but much slower in midsummer. So use your eyes and hands, not just dates on a planner, to make those decisions. Are you interested in rotational grazing but don't know where to start? Well, you're not alone, but with just a bit of planning and observation and the willingness to try something new, you can do it. So let's take a look at our board. This is a pretty simple 4-step approach you can take to start on your rotational grazing journey. The first thing you're going to want to do is estimate your forage supply. You can do this directly by going out and clipping or use a database online. Web soil survey is a great option. So in our example, say we have a 15-acre tall fescue pasture that has approximately 6,000 pounds of forage per acre, 3 tons per acre. That's going to be common for this region of Virginia. We're going to take that 6,000 pounds and multiply that by 15, so our 15 acres, and then by 0.5. 0.5 is going to be our utilization. So that's a little conservative, but we're going to go with that. That gives us 45,000 pounds of available forage in our 15-acre tall fescue paddock. So that's how much we have available. Now we need to see how much is in demand. So for forage demand, say we have a 1,000-pound cow. A 1,000-pound cow, they're going to consume around 2.5 to 3% of their body weight each day. So we'll take our 1,000-pound cow and multiply that by 0.25. So that cow is going to consume about 25 pounds a day. And for 6 months, say we wanted to look at how long can we stock this 15-acre tall fescue pasture for 6 months, that cow is going to consume 4,500 pounds a day. Now we take our forage supply, what we've got, and divide that by our demand, what we need. 45,000 divided by 4,500. That 15-acre tall fescue pasture can support 10 cows. So we could feed 10 cows over our 6-month period. This is where we start to get a little bit more into the weeds, but now we need to think about, how many paddocks do we actually need? How many can we divide that 15-acre pasture into? So what we'll do is assume we want to do a 5-day grazing period in each paddock. Again, this is getting started. You're going to want to use the grass height as your tell. And we want to give a 30-day rest period for each of our paddocks. 30 days of rest divided by a 5-day grazing period, we need 6 paddocks at the least. So on this diagram here, I have 6 paddocks plus 1 additional, so 7. That 1 additional is going to make sure that we give our first paddock 30 days of full rest. So why is rotational bale grazing, being researched? Why is it a system that's being promoted? Well, even nutrient distribution is one way. Each bale carries nutrients harvested from a different part of your field. When animals consume that hay and deposit that manure, they're feeding themselves and the soil right where it's needed. So for my research, I took soil samples of each paddock and located the areas where there was the lowest amount of phosphorus. And that is where I placed my hay bales. So we were trying to increase nutrients where they were needed and mitigate them, or even see decreases where nutrients weren't needed. Results showed that we were able to have a spatial distribution of nutrients, particularly for potassium. Phosphorus actually increased across the whole paddock, regardless if there was a bale placed on that soil or not. There's a lot more potassium in a hay bale than there is phosphorus. And again, this was about a 2-year study. So I think with an even longer term study, we would be able to see, some increases in phosphorus where it's needed and not where it's not. In an overused sacrifice lot, you're building up all of those nutrients and you're increasing soil compaction. So you're bringing the tractor onto the soil during those wet winter months when it's most susceptible. In these rotational bale grazing systems, you're placing hay bales before winter hay feeding begins. Another huge thing we can't skip over when talking about rotational bale grazing is building organic matter and soil health. So that leftover hay, that manure, and that trampled forage are going to break down over time. They're feeding soil microbes, improving water infiltration, and building your topsoil, which is the foundation of a productive pasture. You can improve forage quality and quantity in spring. So sites receiving nutrient inputs and rest typically green up earlier. That often means better stands of tall fescue, clover, and as I said, even some crabgrass, all favorites of grazing animals. There are some practical tips for success, and that is to plan your bale layout beforehand. Walk your fields in the fall and identify well-drained, accessible spots to place bales. Avoid low-lying areas, wet areas that might get rutted or freeze and thaw damage. Space bales appropriately so cattle have room to graze the surrounding forage without crowding. And adjust based on your pasture size and fencing options. One thing with rotational bale grazing that I will say is you need to be flexible. It's a system that you can work and make for you, but flexibility is key. If we do have a very wet few days, having a spot that you could potentially move cattle to a few days off of the pasture area. What I want to leave you with and my final thoughts on rotational bale grazing is that it can transform what you see as a costly winter chore into an opportunity for regeneration, building soil, boosting forage, and increasing system resilience. If you're looking to cut feed costs, reduce labor, improve soil health, and create more flexible grazing options, rotational bale grazing is a tool worth trying. So next time you're lining up your hay for winter, don't just think about getting through the season, think about building a stronger, healthier system. While I was doing this for my grad research, I have to give so many props to the crew. They were the ones coming out here every day and or every few days and moving the polywire and moving these hay rings. So when talking to them, a few tips and tricks that they had from the farm crew was it can be a straightforward and simple process, but it does require advanced planning. Rotational bale grazing is all about gaining experience. At the beginning, you'll have uncertainty about when to move cattle, how much hay waste to leave if you're going to reseed your bale areas, but it all comes with experience. Again, be flexible. Also, use a poly hay ring instead of a metal. It's lighter and it's not going to conduct electricity. One suggestion was to remove net wrap before placing bales and place loose bales on their flat end and firm bales on their curved side on relatively flat ground, because that's going to be best for water shedding. For my research, what we did is each of our paddocks was about 2 acres, and we divided those into half-acre strips. So this is an example of it's time to move the cattle. They finished their first hay ring, and now they're moving on to the next. So we have 2 poly wires set up. So we would just roll up this first one, and then take your hay ring and roll it to its next destination. We'll place our poly hay ring over top of it, and now cattle still have access to their water trough. So they still have access to that first strip that they grazed, now access to a new bale. And when they finish this bale, we would repeat the process. Now let's go there, the manure, that liquid gold. Because if you're not looking behind your livestock, you're missing half the story. This isn't about consistency, it's about intake, balance, and timing. Loose and runny, too much water, lush forage, or imbalance in protein and energy. Firm and stacked and dry, might be underfeeding or low digestibility. Flat, shiny pancakes, that's the sweet spot. Good fiber, balanced protein, and energy, and optimal intake. Maybe animals and cows aren't much different than humans after all. You can tell a lot by how grazing management is working just by what you step over. It's real-time feedback from the rumen. And don't overlook your knife or your hands. Split a stem, look inside, dig up a root crown. How deep, how branched, how alive. Smell the soil. Is it rich and earthy, or is it sour and metallic? Those are all signs. You're not just gathering samples, you're building a relationship with the land. Here's the thing, none of these tools require a lab coat, but they do require attention. They make things visible and they slow us down. They create moments where someone says, I never noticed that before. And that's where the learning happens. These tools don't just give you data, they help you tell the story of a pasture and train others to see it too. This is how we build better grazers. One stick, one scoop, one manure patty, one square at a time. Healthy pastures aren't born, they're built. Built through small decisions, made season by season, year after year. They're shaped by when you graze, how long you rest, what you feed, and where you plant. Whether you're seeding a new stand, setting up a grazing plan, stockpiling for dry months, or rolling out hay in January. Pause and ask yourself, what does this decision do for my soil? What does it do for my forage? What does it do for my animals, not just now, but next season? Dig deeper, ask questions, reach out to your local extension agent or your soil and water conservation district. They've walked pastures, they've seen what works and what doesn't in your region. But most importantly, manage with intention, because grazing isn't just about today's gain or this week's forage, it's about building the system you want for the future. Healthier soils, stronger root systems, more resilient pastures, and livestock that thrive year after year. The choices you make today are already shaping next season, so manage like it matters, because it does.
This virtual pasture walk is brought to you by the West Virginia Conservation Agency, funded through the NRCS Grazing Lands Conservation Initiative. For similar content, please visit grazingprofessionals.us.